Okay, so this is here, this is your Moodle page, and if you go here you have all the instructions how you can download Quartz software in your laptop. And here, this is a lab 1, so if I open it, it will open here, okay? Then if you go inside this link, you will have this my file, which you can open it like this, okay? Then if you go to lab 1, it has all the instructions how you can create a project, okay, which I will explain in the video also. So there are different steps like create a project, then create a schematic diagram, then create a Verilog code, then synthesize, and then waveform, and then create a symbol. Okay, I will explain you all the steps. So first you will go to the search and you will write Quartz QU, and it will open here. You can open it, and you can go to new project wizard. You will click next. Now this step is very important. Here you have to create a new folder on the desktop and then provide the path of that folder here. If you don't do this step, then this simulation will not work. Okay, so for this you go to the desktop and make here new folder and name it as lab1. Okay, now this folder you will give the path here, right here, and you go to desktop and this here, select folder and write the same name here. Next, 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 and finish. Now it will open here. Okay, this kind of screen will come. Now you go to the file, press new, and click on block diagram, press OK. Now this is your screen. From here you can put your symbol. From here you can put inputs. If you go to the question, bring this here, copy, Control C and Control V. Okay. Okay, now here you can see that P, Q, in logic terms, it is AND. Then plus is OR, then Q is AND with OR. Similarly here, S2, P and Q is AND, and it is complement means not gate. So it means how many AND gates I need. You can click here and you can write text here. AND gates, how many? 1, 2, 3, 3. Or gate. How many? Only 1 plus. So I need only 1 OR gate. How many NOT gates? 2. Why? Because 1 complement here, 1 here. So 2. So you go here, write here in small letters, and 2. 2 means 2 inputs. How many I need? 3. 2, 3. Escape. Then OR gate, OR 2. I need only 1. Escape. I need NOT gate. NOT. How many I need? 2. That's it. Then I need inputs. How many inputs? P, Q, and R. So it means I need 3 inputs. 1, 2, 3. How many outputs I need? Outputs 1 and 2 because S1 and S2. So rename them. Double click. Double click here. Name it P. Double click here. Name it Q. And double click here R. Okay. Similarly for the outputs. This is S1. This is S2. Now how we will connect? Using this equation. Okay, so PQ complement. And now next another point. You have to, you see this plus, when it comes here, there is a square box. Then you can release the mouse. Many students, they did yesterday like this. They did like this. This is wrong. It will give you error. So delete, and you have to make it until the box. Then it should be like this. There should be no dot. Then same for the Q. Q is complement. So you see there is no dot coming. So this is correct. Now this is PQ dash plus QR. It means that I will take one input from here and the other will be here. You see this plus, I click the mouse and connect it here. Now this is wrong. This dot should not come here, okay? I have to remove it. Whenever you get like this, you have to remove it. Okay. Now this is fine. Now this is PQ. This is PQ and this is PQ dash. So this is PQ dash and this is QR. Now they are OR. Now this is wrong. You can also make Control Z and it will go away. Now this is correct. I can delete these. Now the second equation, PQ whole complement. It means that P, I will get it from here. P and Q. Q is already here. Now you see two dots, this is fine. And then whole complement. Now this is wrong because it gives another node. So you have to be careful about the nodes. Then, now this is also wrong. Delete. Okay, S2. Okay. Now this is your final circuit. Okay, now your next step is to compile the circuit. First, you will click here. You will, okay, first you will save it as lab 1. This is lab 1. Okay, save. And it will come here. Right click and set it as top level entity so that this will run first. Now you go to the processing and start compilation. Here you can see 1%, 4%. When this 1% goes above 10%, it means your program will run. If it is not running till 10%, it means there are errors. So you have to wait for this. Now this is working. Okay, now if you go here, you have to wait for this for compilation, okay? Also time is running here. So you can see that this compilation is in progress from here. And also from here. Now this is done. After this, what you will do, you will go to your this file and here screenshot of the schematic diagram. So I need the screenshot with this showing 0 errors, all these tick, and this 100%. And this. So you will take snipping tool, you will write here snipping. Another thing is you have to write your name. Click on this text and you can write your name and ID. Then you will go to the snipping tool, new, you will take this and you will put it here, Control V. Okay, so schematic means the block diagram. So this is the block diagram. Okay, then timing diagram of the schematic. So how we will create a timing diagram? So you will go to the file again, you will go to new, you will go down, and this verification and debugging university program file. Okay, now here first you will go to the edit, you will set end time. End time will be 800 nanosecond. Now you will go to edit again. And okay, so you will go to edit again and then insert. Okay, you will go to insert node or bus, and you will go to node finder, and from node finder you will go to the list. So you can see all your inputs and outputs are here. You can send them, select and send them one by one, or if you select all of them will go. Okay, and then okay. So you can see here. Now click on this and then click on this override clock, and you can put here 800. The second one 400. You so always make half the next time. So half of 400 is 200. Okay, now you will go to simulation, run waveform. So this will come. Now this is completed successfully and you will see the output. Now this is out. So you can see, you can make it with the cursor. So you can see here, P is 0, Q is 0, and R is 1. So S1 is 0, S2 is 1. So you can check this using the truth table, which I explained you in my class yesterday. So this is done until here. Then you will take screenshot of this waveform. And you will paste it here. Here, timing diagram of schematic. So now Verilog code. So you will go to the file again, new, and this is Verilog HDF. Here you can write your code. So if you want to make comments, you can write it Verilog. And you can copy paste this here with double dots and then double slash. Okay. So you will write module. The name of the module will be this same. Okay, V in Verilog. 1. You put the number of inputs P, Q, R, S1, S2, and semicolon. Then input is P, Q, R. Output is S1, S2. You have to put semicolon, and also remember, if this is small, all of them should be small, okay? If this is capital, all of them should be capital. Then assign S1 equals this one, PQ dash, P and Q, Q complement, or you can write or with this shift and then next button next to the enter, and Q and R. Okay, then assign S2 equals complement of E and Q. Don't forget to put the semicolon. Then that's it. After that, you will go to make it save. Okay, then processing, start compilation. Now this will start to run, and here also you can see that this percentage is showing. So this is, as this is greater than 9%, so it means there is no error. So you see 0 errors. So this, you will take a screenshot of this. And you will post it here. Here, screenshot of Verilog code. So this is the code without any errors. And also one more thing, you have to put your name here. Okay, then you take screenshot. Set its top level entity. Now we will go for timing diagram. So new timing diagram for the Verilog code. Okay, same steps, edit, set time 800 millisecond, edit, insert node purpose, node finder, list, and okay, same. This will be 800. This will be 400. This will be 200. Okay. Simulate, run. So here this waveform will be created for the Verilog code. Okay, so there is an error. Okay, let's see what is this error. Mhm. Okay, I think I have to run this again. Okay, after this step, then the last step is to put the symbol. Okay, so you will go to the Quartz software. You will go here. And let's wait. Okay, and then you will go here, file, create. Okay, you will open this Verilog. Then you go to create and then create symbol from the current file. So a symbol is created. What you will do, you will go to, you go here, and symbol files is just unique quarter file. Okay, so what you will do, you will go here, you will scroll up. So this project, and this is your symbol. Okay. Then you can just take screenshot of this with your name also. You have to put your name here and you will put the symbol file here. Okay. That's it. If you have any questions, you can ask me in the class.